Good morning, everyone, and welcome to the Usable Software Design session. My name is Alex, and I'm a polyglot programmer, trainer, and coach at Mozaic Works. And for the past 7 years, I lived based on this belief that we as developers deserve better. And I try to do my best with my community work and working with teams and going to various places, learning more to make this happen. And this is like the final idea that came to my mind that I hope will support an improvement of our developer lives. And here's why I think that we deserve better, because we had like the agile movement and we have software craftsmanship, and these are all good things. And we keep learning from each other and we keep improving, but I think we still have these types of problems. Now, hopefully you didn't very recently. I remember when I started doing programming that I spent about 6 months searching for a bug. The problem wasn't a missing period, but it was a wrong type. I was doing C++, and it was an intermittent bug that kept appearing. Or maybe this. Now probably it's not with compilers anymore. But you probably lived with bugs, maybe. Changed something to fix a bug and then got more. Or this. Now, I was never really very afraid to debug, but you never know. And this is not a programmer saying that, but I think it reflects a lot of maybe what we are living through sometimes as developers. Because we all know that that's the only good measurement of code quality. Right? So when I looked at these things, they reminded me of something else. There is a guy called Jacques. He was an artist, and in the 60s, he created a thing called the Catalog of Impossible Things. And basically what he did was he took normal objects that we use every day and tried to make them as impossible to use as possible. And as you can see, I know it's not a very good photo, but he has he wears some glasses that one of the lens is actually a clock, so it's completely useless. Or this one. You can never pour coffee with this without burning your hand. Or, yeah, this one, which is apparently sprays because it can hold a lot more liquid than a usual bottle, but then you cannot actually pour it anywhere. Or this one, which is and it's like sometimes when we are using, especially working with legacy systems or things like that, it's like we are feeling the same things. It's like we are working with impossible objects. Now the thing is, I haven't heard about Jack Hardeman by reading about it and by searching, the artists who did impossible things. No. The way I heard about him was from a book, this book. This guy is called Donald Norman, and he wrote the book that started the revolution of user-centered design and of usability. It worked at Apple at some point because everybody did who was working on usability. And he said something that resonates with me a lot. This is a quote from a book. He said, "It is the duty of machines and those who design them to understand people. It is not our duty to understand the arbitrary, meaningless dictates of machines." And he uses the impossible objects to illustrate like how design can go wrong and how you can think about design in a way that doesn't help its user. So this started this revolution of user-centric design. And the reason we now have like nice smartphones and web applications that we can actually use and don't look like very bad, ugly thing, right, is because of these guys. Because they put a lot of work into improving usability, into improving the design. But the most important thing was, and the revolution of design, was that they started thinking about it as being with the user in the center. It's user-centered. It's not about, do whatever you can to fix it. It puts the user in the center. And this was the most important mind shift in the history of design in the past years. And it's fairly recent because, so the book appeared in 1980s. And if you think about, maybe you haven't seen websites, the first original, first versions of websites, they were really bad. And so this got me thinking, because I read a lot about design and about software design and so on, but when we think about design and user-centric design, it's very easy. I mean, you design a chair, it's very clear who uses it. You design a tool, it's very clear who uses it. But when you design software, who's using it? And it cannot be the customer. It cannot be the end user, because they don't care how you write your code. They just care about the fact that it works, right? It has to work, it has to solve my problems, and that's it. Whenever I'm using the applications, I'm using WordPress, for example, which is, if you look at the code, is very badly written, but it works, so I don't care, right? So the user of the software design cannot be the end user. He's the user of the final product, of the application, right? Of the compiled thing, of the packaged thing, of the interface. But it's not the user of software design. The user of software design, and this was a very hard thing to figure out, is actually the developer. Is everybody who needs to go into the code and change it and do something with it. But now if we think about this, and how about doing developer-centric software design? Or how I called it usable software design. What would that mean? Well, it would mean that we can take practices that were developed in the area of user experience and usability and start applying them to the area of software design. And I'm going to go a bit into details about what we can take from user experience and apply to software design. Now I have to tell you that this idea is very new. So it came to me at the beginning of this year. And while we kept discussing into a close group in Europe about this, it's still very new. So I don't have all the answers, and I don't have like a receipt you can follow or recite. But there are some things that I think will be interesting for you. The first thing that user experience people do is to figure out the user scenarios. Like you go in the application, log in, and then post a tweet or whatever you are doing, and then you can see. So this is the user scenario. Now what's a user scenario for developers, where it's changing code? And the next thing that they do once they figure out like which are the steps is to look at each step and see how it can be improved, how we can do it faster, how you can make it better for the user. So I'm only going to take a few steps because we are short on time and there's a lot of things we can talk about. But just if you take this one, figure out what you need to change. So the question is, let's say somebody comes to you and tells you, I need to change some feature. I need to, I don't know, move a button from there to there, or add a new button that does something else, and so on. How easy it is for you to figure out where to go and change? Like, this is the first usability question that you should answer. And if it takes you like 5 minutes, then it's probably okay. If it takes you like 2 days, it starts being a real problem. If it takes you weeks, then it's already very, very bad. And the most important thing is, in this case, is how easy can you reason about how the code behaves just based on how it looks. Like, the ideal would be to go in your IDE, look there and say, hey, that's where I need to change. And that's all. Okay? Not asking anybody, you just know. You go there and you just know somehow. Well, what can tell you where to change the code? Well, is the way the code is structured. And fortunately, Simon talked a bit about this yesterday. But if you look at this example, it's like, can you tell me what this does?
The two classes?
No, like the whole thing.
It's pretty good.
Generates an invoice.
Generates an invoice. So it's what Simon talked about, like feature-dependent namespaces. You use namespaces to express what the feature is, instead of expressing other things, like the controllers or views or whatever. So this could be something that helps. Now another example is how you structure your modules. And I like the fact that, well, Simon told yesterday about the fact that we don't have like a module keyword in Java. And I think that's a pity, because we would need something like that. But anyway, if you look at this, this is a list of modules from this system. Can you tell me what these things do? This is mostly just based on the names. Right? This does currency conversion, this converts HTML to PDF, it's pretty clear. This one is poorly named because it should be CRM client. But I left it on purpose to show you it can still be, there's still work to do. So just by doing that and extracting small modules with very clear names and to do one thing and do it well and so on, it's already a better way of understanding where to go and change things. If I tell you, so we are using now Romanian National Bank to do currency conversion, but now I want you to use another type of provider, you will know that you have to go here. It's very easy. So the next thing is, let's say you figured out where to go. How easy it is to get there? If you have like a very large application with hundreds of solutions or packages or whatever, it could get really tough to go to wherever you want to go. So it can help if you know exactly what module or namespace to go look in. And that's the first thing. But then the names are important. And I think that the important thing is to have consistent, memorable, precise names. And what I mean by that is, imagine you go into your IDE and you can search for a type, right? And your IDE is very good at taking you exactly at the type that you need. But maybe you don't know exactly what you're dealing with. You want to change the invoice or whatever. So you just type in invoice and it will show you a list of classes that fit this. Okay? How do you know which one is the right one to change? Well, first, based on module and namespace, because they typically tell you where they are located. And second of all is based on the other things that you use about names. Right? Maybe it's an invoice controller, an invoice generator, an invoice, or something. So you'll know exactly where to go once you have your namings memorable and precise. Now, consistent, if I'm looking for something related to invoice, but it's called, I don't know, ABC, it will be very tough to figure it out. Okay? Now, this is a silly example, but maybe you use synonyms or stuff like that. If you don't use synonyms, you just use one name for the whole thing, you'll get there immediately. The inheritance tree is another thing, because if you need to go to a class, but you are using like dependency injection, you'll go very easily to the interface, maybe. But then, which is the class that you actually want? If you have a very deep inheritance, then it will be tough to get there, unless it's very precise and memorable and so on. So let me give you an example of consistency. This is, again, this was an application that I tried to develop based on these rules. So you can see that each of the namespaces has a very consistent structure. It has a controller, a request, and a view. Controller, request, and a view. And they are named based on what they do. And they have the generate invoice part in them. So it's very easy to navigate to the right. It will tell you where to go. Now, if you are using modules, what I'm missing for modules nowadays is a way to specify their API. Because we tend to call everything from inside modules. And it used to be that in C, it's a very interesting thing, but in C, we had much better interfaces for modules. You had to write a .h file that had all the functions that you could call. And those are the only functions that you could call, because you had no idea what else is in there. Nowadays, it's a bit more complicated because we tend to make stuff public and all that. So what I'm using here is like the facade pattern, but it should actually be called API or something like that. And it creates something for you that you can use in order to go. Now this is very helpful because if you have a clear API, then you'll know there's only one thing to call. It's a very clear path through the code, so you know how to navigate to the right thing. Now, it may seem a lot, but this is just the beginning, because I can actually give you a definition of what usable software design is. So it's basically any code structure that exhibits quality similar to usability. And what do I mean by that? If you are looking to the definition of usability, it says like usability means that the design has a 5 quality structure, quality components. The first one is learnability. So imagine you get a new application on your mobile. How fast can you start using it? Do you need a manual? I haven't seen manuals nowadays, not a lot. Why is that? Because the applications were designed so that it's very easy to learn them. It's very clear where to go, what to do, and so on. Now, let me ask you the other question. How long does it take for a new developer to become productive in your team? And why is that? It's because they cannot learn the existing software design very quickly. So we are missing on learnability. The second one is efficiency. So let's say you've already learned how to use an application. How fast can you do whatever you want to do? Because it's annoying if it takes a long time. So we want to optimize this. Memorability. Let's say that you don't use the application for a while, and then you go back to it. How fast is to become efficient? That's what memorability is. Errors. It's annoying to get like strange error messages when you are using applications. So one of the things you do as a user experience designer is to figure out what errors you can make and how to recover from them in a very nice manner. Okay, how can you apply this to software design? So again, I cannot give you a full recite, just a few ideas. One of the things that user experience people do is to define personas. And this is very important because not all users are the same. We build an application for doctors nowadays, but we have various types of doctors. Like we have students who are very well versed in internet and using mobile phones and smartphones and stuff like that. But we also have like the 70-year-old GP who has glasses and can barely type. Okay. So how can you optimize for both these people? Well, you have to think about each of them. You have to give the person who has glasses a way to increase the fonts or in a nice manner so that they can see better what's going on, and stuff like that. Now, the developer personas are a bit different, but it's the same idea. There's one thing, so kernel developers have very different needs from front-end JavaScript developers. I think we can all agree with that, right? So the idea is not to push people into like, you need to do that practice and do that thing and do the other thing. The idea is to start from the persona because you are doing user-centric design, developer-centric software design. Okay? So what do these guys need? And it depends on the people, actually. I plan to research a bit more on this topic, but it's already very large. It's enough, however, to start thinking about this way. Who are we? What are we building here? Where do we fit? What do we need? And when I discussed this with Johan Martinson, who is a guy from France, he went back to one of his teams and said, how about making a team agreement? And that's what they came up with. They said, look, he was trying to push practices like clean code and TDD and all that stuff, and people got tired because he's the guy pushing them to do things that, why should we do that, and so on. So he went back and said, let's define this. Usable software design means to us that first, it is written for developers to read. Second, it is easy to find where to modify the code. Third, any modification has a minimal ripple effect. So whenever you change something, it doesn't break in 10 other places. It is easy and fast to validate that we did the right thing, and we don't have to do similar modifications in the same place, in multiple places. Now, he wrote a blog post, and you will get the slides after the conference, but you can also search for this, a federating concept. And this completely changed the conversation. So he wasn't anymore the guy pushing for like clean code and so on. He was the guy who said, how about we agree on that, because this makes everyone's lives better. Like, it makes your life better if you can actually read what you are trying to change. So I think we can all agree with that. So starting from a team agreement, you can actually go to certain practices. But it's a much better way of doing it. And if you say it is written for developers to read, it might lead you to like define better coding guidelines that this time everybody follows because they know why they are doing it. It might lead to maybe adopting clean code. I don't know. I have no idea, and it's really based on the people. So they can decide what was most useful for them. If you want some, it's easy to find where to modify the code. You start discussing about things like how easy can you navigate to stuff, how consistent are the namings, and so on. So it starts a really useful conversation in the team about what we can do to make our lives better. Now, how about the 5 characteristics? So if we talk about learnability, there are a few things that we can use, like the principle of minimal surprise or readability, things like that. I did basically a usability test on a code base with Johan. So he showed me a class in Node.js, which I'm not very familiar with. And I look at that class, and I had no idea what it was doing, where it was placed in the system, what the system did. And the idea was for him to not give me any help. So I didn't ask any questions about what does this do or so. I had to figure it out by myself. And it was a very interesting experiment. It took me about 15 minutes to figure it out. And in the process, we realized that there were some problems with the design. And we ended up discussing about how we can improve the design of that class and so on. But the first thing that I realized was missing for me was this, usage examples. It was a class somewhere in the middle of the system that took some data in and transformed it into some kind of other data structure. And the name wasn't very clear, so it wasn't very obvious what it was doing. But if it had usage examples, that's when I would be able to say, oh yeah, that's the thing. Now the other thing that was, it had tests, but it was very hard to navigate to them. I tried to go to the test from the Node.js class, but it didn't work. For some reason in IDEA, it didn't work very well. So maybe it's a problem with the design, with the way they structured like the tests. Maybe the test didn't have a consistent naming or things like that. So I couldn't get there, I couldn't read the usages. And this leads to an interesting idea for IDEs. Like, for example, if you could annotate your tests, this is the input, this is the output, and so on, and use that to run them. But then also, whenever you are in a method that is called by the test, to see the usage examples, that would be just awesome, because then you can actually say what this is doing, and very quickly. So I have a list of like change requests to do for JetBrains, but that's another story. The most important thing is actually, when you think about learnability, is to ask yourself this question and to measure. This is very easy to do. So it took me about 15 minutes, but maybe for other people it will take maybe half an hour or so. Grab a colleague that has no idea what you are building, show him a class somewhere in the system, and just let him look at it. And the purpose is to measure how long it takes for him to understand. And that's where you will find a lot of potential design problems. Because if it's not learnable, maybe not even you will remember what's there after a while. Okay, how about efficiency? So it's very useful to have, again, consistency, and fast validation is very useful, because actually doing things means that you also finish them, not that you have a lot of bugs at the end. You keep working them. But this is another point that's important. I have worked in C#, I think it was version 2.0, and they just introduced delegates, and I realized that you could use delegates in C# to do lambda functions. And it was a very nice construct because it reduces a lot of duplication and it's very useful, but nobody in my team could read it. So I decided, okay, I'm not going to use that. It's either I teach them or we are not using them. And it's a conscious decision. How can you test this? Well, I like to ask Claudia, who's working with me on a product, like every 2 weeks when we have the retrospective, I ask her, so what slowed you down in the past 2 weeks? And in the beginning, she told me things like, well, those tests were difficult to write, or those things were, I don't know, hard to change. It took me a long while to figure out the JavaScript stuff, whatever. And we kept redesigning and refactoring the application until we didn't got these problems anymore. So that's a very powerful way of figuring out what to refactor. Just ask the team, what slowed you down, what's the problem? Memorability is kind of efficiency plus learnability, so I'm not going to go into a lot of details here. I think the more interesting thing is how to do error prevention using design. And I'm going to give you an example. Now, first of all, there are a few hints to do that, and these are actually taken from Donald Norman's book. He spends a lot of time talking about the psychology of users and how whenever you use something and it doesn't work as you expect, you tend to blame yourself. And you start thinking that you cannot do it, and then it's a vicious cycle. And that's why he said, it's the duty of the designers to actually make the systems more accessible, and not the duty of the user to learn what the hell you are thinking about. And he came up with this, the most important thing. It's never the user's fault. Whatever they do, it's not their fault. So if you have a lot of bugs in your applications, try not to think that it's your colleague who doesn't know what he's doing. It's the design's fault. What can we do in the design? How can we change it so that that type of issue doesn't appear anymore? And that's probably a hard thing to do. And I'm going to give you an example. We like to do a lot of community events with Tic Tac Toe. And typically people come up with this implementation, like move X and move O for Tic Tac Toe, for the game cards. Now the problem is that you can very easily abuse it. And when I point to people this, they start throwing exceptions. And actually what this means, this doesn't prevent you in any way of writing the bad code. It just gives you an exception at runtime telling you you're stupid. Okay? So how about redesigning it? Well, you could have only one move method, and then the game decides who's the next player. And you cannot use this wrong. Right? It's like, when you try to plug in memory cards, there's only one way of plugging them in. It's the same principle. And you can apply it to software design. There's a full article on our blog about this. I won't go into a lot of details because there are many, many things you can do. But what I did with teams is we started looking at their past bugs, and we really had a conversation about, what's the root cause for this. And I did this with a team that was working with with some devices with firmware written in C, in C++. And it turned out that one of their problems, and it was like for 80% of their bugs, the problem was that they were using, they had a limited number of processes they could run on the device, and they would start other processes. So the easy fix then was to at least introduce a guideline, if not to change the design in such a way that you cannot start a new process. You only have that many processes, and that's it. And it turns out that you can find this if you really look hard at the bugs you have and think about the core problems, the initial cause for them is probably in the design. Now, how about satisfaction? I know this is a developer conference, and having fun while working with legacy systems is probably not something that you can think about. It's something that's strictly personal, but it's still relevant because you know that when you have a satisfaction, when you are using something that's nice to play with, to work with, and so on, you'll get much more things done. And this is relevant for the economical point of view, but it's also relevant for you, because if you do more things, you probably will get a raise in something. So that's useful. Now, being that personal, the only question you can ask is what parts of the system are unpleasant for you to use. And people tend to tell you. And if everybody tells you that it's in the same area, then probably it's a good thing to start refactoring it. Okay, so I'm getting close to the end, and the end is we learned all that, what to tell managers. It's easy. It turns out that usability is something that's very useful also for business, but also for users. That's why it's so powerful. It's the same thing for us. So what can you tell them? Well, you know, now it takes 6 months to integrate a new person in the team. How about we get it to 2 weeks? That's learnability. We need to change our design to make this work, but we can. And we need to test it and so on. How about we implement faster the more typical tasks? So I'm not talking about simple things. I'm talking about, like, if you're working in a web application, it's probably very typical that you start adding like a new form or a new page or whatever. These are typical tasks. They might not be easy because there's a lot to do behind them. Maybe you have validation, maybe you have things like that. Making less mistakes, we'll have less bugs. Why? Because we start redesigning the system based on the past bugs so that they don't repeat anymore. It's all starting to make sense. You can also tell them about satisfaction, because managers know from management literature that people who are more satisfied with their jobs perform better. Now, depending on their manager, they might respond to 1, 2, or 3 of those, but okay, so I'm going to close this by saying that I believe that software developers deserve better. And in the same way that we took usability to improve applications from something that was really, really ugly and really poor to use to something that now is pleasant and you can actually be productive with those. That's what we can do with software design. Now, this is just the beginning, and I won't tell you otherwise. And you can learn more from our blog, because I'm writing a series of articles on this topic. Okay. I don't know if we have time for questions. But
you gave the example with Tic Tac Toe. Yeah, Tic Tac Toe might be a small part of an application.
Yeah.
For example. And this can be done in about, I don't know, 1 day.
Yeah.
How do you prevent that the programmer who is doing this part is not choosing the wrong approach as you presented in the first place, and he is choosing the right? Taking into account that you have to coordinate about 10 people working on the same software, each and everyone has
well, it's a tough question. It's always a tough question to do that. The way I'm doing it is I do code reviews. And I look at the code. Every bit of code that's written, we code review it. And if people know a bit more about how to prevent these things, my purpose is to bring real practices, patterns, and so on. Like, this is the thing that you could do instead of doing that.
So basically, you should have a guy or somebody in the team who is doing just this.
Not just this. I mean, I'm not doing just only reviews. But we are reviewing each other's code. And my belief is that once we start putting out like real examples of how to do this, because now I have very simple examples, but there's much more complexities to this situation. And once we have more clear example about what to do and not to do about mistake proofing, then we'll get better in time.